Hello friends, welcome to EC Academy.
In this lecture, let us understand circuit, stick diagram and layout for NAND gate and NOR gate. Before implementing these NAND gate and NOR gate, you need to remember whenever there is a plus sign in logic equations for a PMOS, you need to represent the expression in series, and for NMOS, you need to represent the equation in parallel. And whenever there is an AND operation, you need to represent the equation in parallel for PMOS, and for NMOS, you need to represent it in a series. First, let us take the NAND gate. We can represent NAND gate as y is equal to a dot b whole bar. Here, in a given Boolean equation, while writing the CMOS circuit, you should not simplify this bar because this bar represents complement. Since we are representing complementary metal oxide semiconductor, we should retain this bar as it is. Now, in this equation, A dot B is there, which means AND operation is there between A and B. So, while representing a PMOS in a CMOS circuit, you need to take A and B in parallel, and while representing the NMOS, you need to take A and B in series. So, let us represent that. To write the CMOS circuit, to represent A, let us take a PMOS and let us take one more PMOS in parallel, and let us represent these two as A and B. Let us write the terminals: source, gate and drain, source, gate and drain. Now, the source terminal of these two PMOS are connected to VDD, and drain terminal are shorted and it will be connected to the output. Now, we need to represent AB using NMOS. Since AND operation is there, the input A and B can be represented in series. So let us take NMOS and one more NMOS. These are A and B. Let us write the terminals. Here, the drain terminal of A will be connected to output, and the source terminal of B is connected to ground, which is VSS. So this is the CMOS circuit for NAND gate. Now, let us write the stick diagram. In stick diagram, VDD and VSS are represented by straight line, which is blue color, which represents metal. To represent these two PMOS, let us take P diffusion region, which is represented by yellow line, and to represent NMOS, let us take N diffusion region, which is represented by green line. Now let us take two polysilicon across this. Now first polysilicon represents A. So this will be PMOS with input A, and this will be NMOS with input A. This will be PMOS with input B, and this will be NMOS with input B. In the circuit, for PMOS, both the drain terminal of A and B are shorted. That's why in the layout, we can write the drain terminal of A and B side by side, which represents these two are connected. Now, source terminal of both A and B of PMOS are connected to VDD. So, we can write source terminal for A and B, and these two are connected through contact. In NMOS, source terminal and drain terminal of A and B are connected. So, we can write source of A and drain of B are connected. So, you can see we are writing side by side, which represents these two are connected. Now, source terminal of B is connected to ground. So, let us take the contact and let us connect the source terminal to ground using contact, and drain terminal of A is connected between two drain terminals of A and B of PMOS. So, drain terminal of A in NMOS is connected between two drain terminal of A and B of PMOS, for which output is connected. Now, this is the stick diagram. If you write the stick diagram, easily you can implement the layout. Now let us understand the layout for NAND gate. To write the layout, let us consider the stick diagram. In this stick diagram, we need to replace these lines with the layout or the regions which is specified here. So this is how you can represent an N diffusion region. This is P diffusion region. This is polysilicon. This is how you can represent metal, and this is how you can represent the contact. So these lines will be replaced with these regions so that we can draw the layout. First, let us draw VDD and VSS using metal. Let us take VDD and VSS using metal. Let us draw the P diffusion region and N diffusion region. Let us draw the polysilicon. Now let us extend this polysilicon to write the input A and B. Now source of PMOS should be connected to the VDD. So let us extend these metal so that we can make the connection between the source region of both PMOS transistor. This metal and P diffusion region are connected using contact. Now the source terminal of NMOS, which is having B as input, is connected to metal. So we can use metal and we can make the connection, and we can use contact to connect these two layers. The drain terminal of NMOS with input A is connected between two drain terminals of PMOS. So we can use metal to make the connection. Then use contacts to connect different layers, and let us mark the output. So this is the final layout of NAND gate. Always remember, use lambda based rule to have the spacing and width of each layer. Now let us understand NOR gate, which can be represented as A plus B whole bar. Now let us write the circuit for this equation. Since we are representing complementary metal oxide semiconductor, we need not simplify this bar. This bar represents complementary, and between A and B we are having plus sign, which represents the PMOS should be connected in series with input A and B, and NMOS should be connected in parallel with input A and B. Let us take PMOS in series with input A and B, and let us take NMOS in parallel with input A and B. Now source of NMOS is connected to ground, which is VSS. Both the drain terminal of NMOS along with the drain terminal of PMOS of B are connected to output, and source terminal of PMOS of input A is connected to VDD. Now this is the circuit for NOR gate, which is represented using CMOS, which includes both PMOS and NMOS. Now for this, let us write the stick diagram. To represent VDD and VSS, we'll always use blue color line. Blue color line represents the metal, which is commonly used to represent VDD and VSS. Now let us write P diffusion region with yellow color line, which represents P diffusion, and let us take green color line to represent the N diffusion region. Polysilicon can be represented by red line, and for this polysilicon let us write the input A and B. Now in this stick diagram, this region represents the PMOS with input A this region represents PMOS with input B. This region represents NMOS with input A, and this region represents NMOS with input B. Source terminal of both NMOS are connected to VSS, which is ground. Let us take source terminal of both NMOS and let us connect it to the ground using contact. In PMOS, drain and source terminal of A and B are shorted. That's why let us take drain and source terminal of both PMOS and let us write side by side that represents they are connected with each other. Now source terminal of PMOS with input A is connected to VDD. So let us take source terminal of input and let us connect a contact, and drain terminal of PMOS with input B is connected to both the drain terminal of the NMOS, and in turn it is connected to output. So let us write drain terminal of PMOS with input B and drain terminal of NMOS, which are written side by side. That represents these two drain terminals are shorted, and let us take the metal and make the connection between the drain terminal of NMOS and the drain terminal of PMOS with input B. So from this, let us connect the output. So this represents the stick diagram. From this stick diagram, let us write the layout for NOR gate. To write the layout, let us use these regions. This is N diffusion, P diffusion, polysilicon, metal and contact. To replace this stick diagram to represent the layout. Now VDD and VSS can be represented using metal. Let us represent the P diffusion region and let us represent the N diffusion region and two polysilicon region. Now source terminal of both NMOS are connected to VSS, which is ground. Let us extend this metal and connect VSS with both source terminal of NMOS. Let us use contact to make the connection. The source terminal of PMOS is connected to VDD. Let us extend this metal and connect the source terminal using contact. Now these two drain terminal of NMOS and the drain terminal of PMOS with input B are connected. We can use metal to make the connection. Let us connect these two layers using contact. The same metal we can extend and connect the output. And for these two polysilicon, we can connect the input A and B. So this is the layout for a NOR gate. This is about NAND and NOR gate circuit, stick diagram and layout. I hope you have understood the topic. Thank you.